Well, hello there. We are taking a look today at section 1-3, or the rest of it, and we are going to look at a couple of properties first, and then we're going to solve some equations, which you've done before, and then we're going to look at FOILing, which you've also probably done before. So, should hopefully be able to skip forward if you need to, but also make sure to watch and take some notes that'll be necessary for any open note quizzes or worksheets that you're going to work on. So, for this first part, let's talk about these. You saw them in geometry. Reflexive. So reflexive just means, I always think of it as very flexible, because you could just say that b plus 12 is also equal to b plus 12 itself, or maybe a reflection in the mirror equaling itself. Symmetric is like a butterfly's wings. So the left side, if we kind of flip it, it matches the right side here. So I kind of always think of this as like one of the wings. That's not really pretty, but you know, butterflies and moths aren't always the prettiest. And then this matches, and I'm again not very symmetrical myself, but it matches on the left side to the right side if we kind of flip it. Symmetrical. Transitive, think of like a choo-choo train, and we think of it a big long thing here. And maybe the front part of our train is going to then be paired up with the back part of our train because they both equal the same thing. So if A equals B and B equals C, then of course A is going to equal C. So you can kind of almost cut out that middle part of your choo-choo train and just put the beginning equal to the end. Substitution, we know, like a substitute teacher, they're going to plug in for something else. So let's take a look at some of these properties here, an example. And we have x minus 2.03 equaling x minus 2.03. Well, that's the exact same thing on the left as it is on the right, same order and everything. So when it equals itself, it's reflexive. And again, it's just going to take maybe some flashcards or some practice with these. At least there's not a whole lot that you're going to have to memorize. The next one, B, 9 equals x, then x equals 9. Well, it's very close to being the same thing, but look at the order or how it's kind of written. It's a little bit different. It's almost like you could flip this onto that one. So we've got some symmetry going on here. So this is going to be the symmetric property. And we're not going to get too involved with the property of equality, but basically it is. Let's take a look at some solving. So we know that when we solve things, we have to do some properties in a sense. You don't really think of them as properties. You think of it as undoing it and just getting it away. But really, these are properties of equality. So we've got subtraction and addition. When you're trying to get rid of subtraction, you use addition, use the opposite. But it is a property that you're actually doing when you're solving. So let's take a look at this first one. So before we get too crazy, draw a fence down the line. Separates the equal sign. All right, got a little song for everything, don't we? So we are going to solve. So basically, we have a variable over here and a constant, and we have a constant over here. So anytime we've got a variable, we want to get that constant away from that variable. We want to keep variables on one side and constants on the other. So how would I undo a positive 8? Well, I would subtract 8 if my pen was working. We would subtract 8. And whatever we do to one side, we have to do to the other side. So now we have 6 on this side, and we have a negative 6r on this side. So now we want to get that variable alone. How do we undo the multiplication that's happening? With its opposite, with the division property of equality. So now we have r on this side, and over here 6 divided by negative 6 is negative 1. So r equals negative 1, and we're done. For number 2, we have a half x. And we have just that, no constants to get away. So we want to undo the half. So if you want to divide by a half, we don't really divide by fractions though, do we? We multiply by their reciprocal. So we're going to multiply by this reciprocal, or 2 over 1, or 2. And whatever we do to one side, we have to do to the other. So 1/2 times 2 gets you 1 or cancels out there. And 2 times 18, 36. All right, let's take a look at number 3, and then I'm going to have you do number 4 on your own. This one has some distributing because we have parentheses here. So that's going to be our first step, is to check for that distributing and complete that. So 53 equals 3y minus 6 minus 6y plus 2. Careful with that negative times a negative, making it a positive. All right, next step, combine like terms on the same side. So for example, we have variable, variable, constant, constant. So see how this variable and this variable, they match up. They're on the same side of the equal sign. So you can go ahead and just add those together since they're on the same side. So 3y minus 6y, and yeah, we'll start a new color here, is negative 3y. Now we can add the constants together, negative 6 and positive 2, which is negative 4. And we have our 53 over here. So now we're very similar to what we had in number 1, where we have our variable, constant, constant. We want to get those constants together. So here's our variable. Let's move this, get this to the other side. Here's when we undo because it's on the other side. So we want to add 4. 57 equals negative 3y. And then we want to divide. So not everything is going to be a pretty number. We are so used to everything being pretty numbers. Now, I know that sometimes that's a red flag, but in this case, it is going to be negative 19, but on your worksheet, you will see some questions that have a decimal. So don't freak out if you're like, wait, I have a decimal. Just check the answer key, see if you're right. But again, don't always freak out if there is a decimal. We're getting into higher math classes where everything's not always going to be a pretty number. But it is a cause to check. You do want to get into that habit of checking. So go ahead and try number 4 now. Pause and check when you're ready. All right, so let's go ahead and talk through this one. First step is going to be distributing. And we get 30 minus 20v equals v plus 21. So you can either move the variable or you can move the constant. In this case, either one is going to get you those things together that you need. So first step, I moved the variable to the other variable. Then you want to move the constant to the other constant. So then we divide by 21 on both sides and we get a fraction here. So you can either reduce that fraction to 3/7 or you could write it as a decimal, but most of the time we want to keep it accurate. So keeping it as that simplified fraction is going to be better. Otherwise it's 0.43 if you rounded to the nearest hundredth there. All right, let's go ahead and solve for a specific variable here. So this gets a little tricky. You have done this before, but we're looking for v by itself. So again, we're undoing things. So v is what I want. Then I want to get rid of this thing that's being subtracted. And again, if you need to draw that line, you can. So the first step, we're going to add gt squared since it's being subtracted. So right now we have h plus gt squared equaling vt. Now the last step to get v alone is to undo this multiplication. And how do we undo it? Well, we undo it with division. And we're not going to be simplifying any further with this. We're just going to leave it like that. That plus sign kind of looks like a T, but it's a plus. So go ahead and try number 6 on your own. Don't get too frustrated. Again, start with the 3. Undoing division with multiplication. Then undo the plus 1. Then undo the 2. And try that to get the D by itself. Check when you're ready. All right, take a look at my steps. Pause if you need to look at them a little deeper, or maybe put a star next to it if you're still having some questions over that section. And then the last thing we're going to talk about is basically foiling, as you know it. But we've got two methods. You can use that FOIL method. We've got binomials here, so that means just two terms. These are all examples of things that are two terms. So when we FOIL, we do the first, we do the outer multiplied, we do the inner, and then we do the last. And you can kind of see it colorized here. And then we combine like terms. Maybe, though, you want a new method, where it's kind of more graphically organized, where you're still multiplying the same things, but you're putting them in boxes, and then you're multiplying. So, for example, you're taking A times B and C times D, and you're taking A times C and A times D, and B times C, and B times D, and then you're combining those like terms if you have any inside your box. So either method's going to be fine, whatever you choose. We're going to go ahead and do two examples, and then I'm going to leave you to do the last two on your own. All right, so for the first one, I'm going to use the FOIL method. For the second one, I'm going to use the Punnett square method, and then you can choose whatever you want to do for 3 and 4. So for the first one, so x times x is x squared. O, outer, so the outside one and the outside one, 8 times x is 8x. I, inner, so the two inside ones, negative 6x. And last, negative 6 times 8, which is 48, and it's negative. So now what we want to do is combine any like terms, which we've got two x's here. We can't combine it with the x squared because that's x squared, not just x. So 8 minus 6, so a positive 2x, and we're done. There's our final answer. All right, now let's take a look at the Punnett square. Well, this is squared, which means we have 3x plus 5 times 3x plus 5, so there's really two of them. So we're going to put one binomial up here and the other binomial here. And now we're going to multiply. So we're going to take 3x times 3x and we're going to put it in this box, which would be a 9x squared. We're going to take the top thing, which would be our term, times 5, and we're going to put them together in the box. They kind of match up in 15x. 5 times 3x here, 15x. And 5 times 5 going in here, 25. So now we look for any like terms on this one, and yep, we've got 15x and 15x. Those are definitely alike. So let's start with our 9x squared. 15 and 15, that makes 30, and we keep it as just x, and then the 25. So go ahead and choose whichever method you like and try 3 and 4 and check when you're ready. All right, number 3 should be 25x squared minus 16, and number 4 should be 6y squared plus 19y plus 10. If you have questions on that, at the bottom when you go to write a quick little summary here, or if you have any questions, there's the time to write that question out, so you make sure to ask that in class. And I will see you tomorrow.